Okay, the goal of this video is to make sense out of map scales and scale models. Frequently that's confusing to people, and so I'd like to be able to give a good introduction. When you look at a model like the one I'm looking at on the screen here, this is a model ship in some kind of maritime museum apparently, and clearly it's not the same size as the actual ship. That'd be impractical. Okay? But it's a scale model in that it's exactly the same shape, and the size of the sails, for instance, related to the size of the mast is the same as on a real ship. So everything is simply shrunk down, like you took a picture of it and then compressed it using Photoshop or something. But anytime you look at a model, you will find somewhere a sense of scale. Maybe it's on a plaque somewhere, or maybe it's on some information, but someplace you'll be told that the scale is maybe 1 inch equals 8 feet. Or maybe 1 inch equals 12 feet, or whatever it is. You'll be told how the size on the model relates to the size in real life. What this would mean, if it's 1 inch equals 8 feet, is this. Anything you see on the model that's an inch long represents something that's 8 feet long in real life. Okay? So if this boat, for instance, on the model has a height of 1 inch, then the boat in real life has a height of 8 feet. Okay? Or if you look at this piece right here, I believe it's called a yard arm. If that on the model is 1 inch, is say 9 inches, then the yard arm in real life would be 72 feet, or 9 times as long. Okay? So the scale simply tells you how the size of something on the model relates to the size of the same thing in real life. It can also be used for very small things. Suppose this is a model of a virus, and the model stands 20 inches tall, as shown right here. Okay? If you want an idea of how big the real thing is, you'd have to find a sense of scale somewhere. And it's shown right here, 1 inch equals 20 nanometers. Okay? So 1 inch on the model, maybe that's the length of this little spike thing here. Let me change colors. So maybe it's the length of that thing there. That might be 1 inch on the model. That piece would be a size of 20 nanometers on an actual virus. Okay? By the way, a nanometer is a millionth of a millimeter. And you might remember millimeters are very small already. It's a tenth of a centimeter. And so a nanometer is a millionth of that. Okay? So when you're looking at these things, they give you a sense of how big the actual thing is compared to the model. Okay? When you look on a map and you see a scale, and here's a scale right down here, okay? That tells you how big things are in real life. I'm going to get a ruler over here, and I'm going to place it right over here next to the scale, and you'll notice that according to this ruler, this 200-foot long piece is represented by ½ an inch on a ruler. Okay, so apparently every ½ inch on the map represents a 200 feet in real life, or 1 inch represents 400 feet. So I can take my ruler, put it up on my map, and move it around to where 0 is right at the intersection of 1st Street and not sure what street that is. Okay. Okay, but I can put it right here, and I can tell that one block on this map is represented by 1 inch on the ruler, so that is 400 feet. When you're solving problems, let's get rid of the ruler, solving problems with these things, you need to first understand the scale, and they'll always give you the scale in some way, usually 1 inch to 2 feet or an equal sign in there, but it tells you how the model represents real life. And when you set these things up, what you'll do is write that as a ratio, 1 inch to 2 feet. Okay? And I like to make a note to myself that this is model size to actual size. Model to actual. Okay? And then, if we're supposed to find out the size of something on the model or the size of something in real life, we'll use this ratio. The way I'll do it is this. This says if the wheels on the car are 1.5 feet of diameter, that's actual size, right? So I'll put 1.5 feet down here because the bottom of the ratio represents actual size. Okay? What is the diameter of the wheels on the model? So I'll just put a D up here for diameter, or X, or whatever variable I choose. Well, now I have a proportion I can solve. Let me just write it with numbers. 1 over 2 equals D over 1.5, and that can be solved easily to find out what D is. So 2D equals 1.5, or D equals 0.75 when you divide. Going on to another problem. In the southwest portion of Washington State, the distance from Bremerton to Shelton in a straight line is about 30 miles. Okay? If the scale on a map shows 1 inch equals 1.5 miles, how far apart will the two cities be on the map? Well, let's first take our scale and write it as a ratio. And I'm going to make a little note over here to myself. This is map to actual. Okay? Well, they want to know how far apart the two cities will be on the map. So I'm looking for a map distance. And I'm given a real life distance of the two cities. There. Now I can simply solve my proportion like anything else. Let's see, 1 times 30 is equal to 1.5x. And so dividing allows me to calculate 30 divided by 1.5 easily, and I get x equals 20. So 20 inches on the map. Okay. Using a different map, the scale of the bottom reads 1 to 25,000. This means that regardless of the units, a distance on the map is 25,000 times smaller than the actual distance. So 1 inch on the map represents a distance of 25,000 inches, and 1 foot on the map represents 25,000 feet. Okay? So basically, my ratio could be written as 1 to 25,000. This is map to actual. Okay. And the units don't matter because these could be inches to inches or feet to feet. Okay. So if the two locations are 3.75 inches apart on the map, okay, so I'll put that 3.75 up on top because the top of the ratio represents map distance. What is the actual distance between them? That's what I'm looking for right there. So now I have a proportion that I can solve easily. 1 times x is x, and 25,000 times 3.75. $93,750. But 93,750 what? Well, this 3.75 was inches. Okay? And if this was inches, 1 inch, apparently the distance between these two cities is 93,750 inches. That's not terribly useful information, but it could be worked with easily enough. If we took that number and, of course, divided it by 12, we would have the distance in feet. And if we divided it again by 5,280, then we'd have the distance in miles. So roughly 1.5 miles. All right? So that gives you an introduction, anyway, to map distance or map and scales. Thanks very much.